Here are more examples of solving rational inequalities. This is a reminder of your steps. When you solve rational inequalities, things that look like that, you want to get it equal to 0, if it's not already. Then you're going to add your fractions together by getting a common denominator, distributing across the top, and combining like terms on the top only. Set the top and the bottom equal to 0 and solve to get your number so you can plot them on a number line. The number from the denominator is always going to be an open circle. The numbers from the numerator depend on whether your original question is less than or greater than, or less than or equal to, and greater than or equal to. Finally, test numbers from each interval to figure out which pieces to shade, and then you can write your shaded intervals in interval notation. So here's our first example. Solve negative x plus 3 over x minus 7 is greater than or equal to 0. Step number 1, get it equal to 0. Done. Step number 2, add together, write it as one fraction. Okay, that's done already too. Step number 3, set the top equal to 0 and the bottom equal to 0 and solve. Step number 4, plot on a number line. But make sure you put them in the right order. 3 comes before 7. The bottom is always an open circle, but the top depends on whatever this symbol is. And since that's a greater than or equal to, this is going to be a closed-in dot. All right, let's figure out what part needs to be shaded. I am going to choose 0 because that's an easy number to sub in. 0 on my number line would fall in here at this first interval. So if I sub in a 0 to the equation, I get negative 3/7, which is that greater than or equal to 0? No, so don't shade. The way the homework is set up, you shade every other interval. That's not necessarily true in other math classes. So if I'm not going to shade here, I would shade and I wouldn't shade. So I'm just going to shade this middle one and then write your answer in interval notation. What part is shaded? From 3 to 7. The only time you use a bracket is if you have a closed-in dot. Let's do one that's a little more exciting. So x is greater than 8 over 2 plus x. Step number 1, get it equal to 0. I'm going to subtract this 8 over 2 plus x over to the left-hand side. I keep adding them or subtracting them over to the left every time rather than subtracting this left side over to the right because I like to have 0 on the right so I can just read my equation straightforward. I don't know if that makes sense, but I recommend you always subtract over here to the left-hand side. Okay, let's add these two fractions together. If you want to write x over 1 to make it clear that that's a fraction, in order to add fractions, you have to get a common denominator. So the second one has an 2 plus x as their denominator, so I need a 2 plus x in this denominator. Whatever you put in the bottom, you need to also put in the top. Now I can subtract across the top x times 2 plus x minus 8, and then write your common denominator in the bottom, the denominator. All right, distribute across the top and combine like terms. I don't have any like terms here, so there we go. Step 2 is done. Add, which means write it as one fraction. All right, step number 3. Set the top and the bottom equal to 0 and solve. When I set the top equal to 0, I can see that it's an x squared already, so I know I'm going to have to factor it. So I'm going to write it in the correct format from x squared to just my x piece to my constant whole number. Okay, so if I set that equal to 0, the way we solve things that are squared is by factoring or using the quadratic formula, or you could complete the square if you wanted to. Set each one of your factors equal to 0, so now I'll have 2 of my answers. All right, the denominator also needs to be set equal to 0 and solved for x. plot on a number line. Remember, the denominator is always an open circle, and the top depends on what symbol they give us in the problem. This one is a greater than or equal to, so I need closed-in dots there. All right, test numbers from each interval. I'm going to test a 0, which would fall in the second interval. I'm going to sub in 0 to my equation. Add across the top, add across the bottom, before you simplify the overall fraction. So is -4 greater than or equal to 0? Is the bigger part of the v facing the bigger number? This is my v. No, so don't shade. So I'm not going to shade here. Your homework's set up where you shade every other interval. That's not necessarily true in other math classes or with other textbooks. And then your final answer is what part of this number line is shaded in from -infinity to -2 and from 2 to 4. You only use brackets if it had a closed-in dot.